In today's class, we're going to talk about Newton's laws of motion. There are three Newton's laws of motion. Okay, let's start with the first law. The Newton's first laws of motion state that an object at rest will remain at rest unless acted upon by a force. You can put that down. An object at rest will remain at rest unless acted upon by a force. Okay, an object in motion will continue in motion unless acted upon by a net force. You can see now, those are the two parts. Those two are the first Newton laws of motion. You understand? I just divide it into two parts. Okay, the first part is that an object at rest will remain at rest unless acted upon by a force. Okay, let me explain that. Let's say I have a table. Please, I want you to pay attention. Let's say I have a table here. This is a table. Okay, I have a box on this table. You understand? This box will not move unless it is acted upon by a force. Okay, there is a force that is currently acting on this box. That force is weight force. We have the weight force. You can put that. You can write it down. Weight force. Weight force is currently acting on this force. What weight force does is that it exerts a downward force on that force, on that box. You understand? Such that that box remain at that position. Do you understand? But the box will not remain on this position if there is no another force that is acting on the box. Please, I want you to understand. There are forces that is currently acting on this box. The first force is the weight force. Do you understand? The other force is the normal force. Let me put it down. The normal force. Okay, what I'm trying to say is that the weight force is a downward force. You understand? The weight force is like the force of gravity. You understand? It's like a gravitational force that causes an object to move downward. You understand what I'm saying? So the weight force is acting upon this box, and there is another force that is keeping this box to be balanced. That force is what? The normal force. The normal force is the force that this table exerts on this box to make it balanced. You understand? You know, for an object to be a stationary point, the net force of that object must be equal to what? 0. Do you understand? That is a balanced force. The force must be balanced. So now let's say the force, it has a mass of 10 kg, and we want to calculate the weight force. The weight force is given by this formula. Weight force is equal to mass times acceleration due to gravity. Do you understand? Okay, so for this I'm going to have mass is what? 10 multiplied by 9.8. Let me use 9.8. That is what? 98 Newton. So the weight force of this box is what? 98 Newton. Now, you know that I told you this box is a stationary point. That is, the box is not moving at all. So we can get the normal force. The normal force is the force that is opposite the weight force. That is the force that keeps the box on the ground. That is the force that the table exerts on this box. So the normal force is also the what? 98 Newton. So the sum of all the force acting on this box is what? 0. Do you understand? Because the weight force is acting in this direction and the normal force is acting, the weight force is acting in this direction and the normal force is acting, the normal force. This is the weight force, okay? The weight force is acting in this direction and the normal force is acting in this direction. So to make the box balance on this table, that means 98 Newton is the normal force and the weight force is also what? 98 Newton. So therefore 98 Newton minus 98 Newton, that is what? 0. Do you understand? Because we have two forces acting in an opposite direction. Okay? Now, that is the first part. In order to displace this object from this position, okay, in order to make this object change position, there will be another force that I'm going to apply on this object to counterpart the balance force. You understand? If the force is still balanced, okay, that means the object will remain at that position. But if I apply another force that will make these two forces imbalance, then the object will change position. Do you understand? That's justified Newton's first laws of motion. An object at rest will remain at rest unless acted upon by a force. Do you understand it now? Okay, let's proceed to the second part. An object in motion will continue in motion unless acted upon by a force. Okay, let's say I have a surface. Let's say I have this surface. Then I roll a ball. I roll a ball in this direction. Let's say I have another surface, a rough surface now. I have a rough surface. I roll this ball in the same direction. Now, let me ask you, which of these balls will cover a large distance? Of course, this is the ball that will cover a long distance. The reason is because this is a rough surface and this is what? A smooth surface. Now, if this ball is rolled on a rough surface, you can see that there will be a lot of friction between this ball and this surface. Do you understand? So therefore, as the ball moves, the friction, and don't forget that friction opposes motion. You understand? Friction is a force that opposes motion. So as the motion of the ball tends to move, as the ball moves, the frictional force will oppose the motion. In that state, the ball will not cover a long distance. But compare this surface to this surface. This ball will cover a distance before it comes to rest. And apart from frictional force, I want you to know that there is another force. There is also air resistance. You understand what I'm saying? There is air resistance that is acting on this box, because there is nowhere we can actually find a place in let's say on this earth. There is nowhere we can actually find a place whereby there is no force that will counterpart an object that is in motion. You understand? That only happens in space. That is outside earth. You understand? So for example, now this doesn't mean that this ball will not come to rest. It will come to rest because there is air resistance. Okay, air resistance. Apart from the air resistance, apart from the frictional force, there is also air resistance that will bring the object in motion to rest. But let's say we find a way of removing the frictional force and there is no air resistance, the object will continue to move. And a typical example is the movement of the earth around the sun. You know, we have the sun here and we have the earth. The earth continue to orbit the sun. You know, till this point, the earth is still orbiting the sun. Why is that so? It is because there is no friction, or in space there is virtually no friction that can oppose the motion of the earth. You understand? So the earth continues to orbit the sun. Let me call this sun, and this is earth. Okay, so an object in motion will continue in motion unless acted upon by a net force. That is the Newton's second laws of motion. It is important to know that even though there is no frictional force that opposes the motion of the ball, that is the first ball, there is also air resistance. You understand? On this earth, you know, there is nowhere we can actually find a place whereby there is no resistance to an object in motion. It is very, very important that you know that. Okay, now how can we apply this? There are two things that I want you to note. Okay, if an object is at rest, the net force is equals to 0. That is the first point. Okay, if an object is at rest, the net force is equals to 0. And if an object is in motion, let's say the object is moving at a constant velocity. Let's say an object is moving at a constant velocity. Now, if an object is moving at a constant velocity, that is, there is no acceleration. Don't forget, acceleration tells us how fast the velocity of an object is changing. Then at constant velocity, there is no acceleration. In that case, acceleration is equal to what? V minus u all over t. Do you understand? Now, for this, I'm going to have v minus u. The v here is what? The final velocity, and u is the initial velocity. Since the object is moving at a constant velocity, the initial velocity and the final velocity will be the same. Do you understand? And if the initial velocity and the final velocity is the same, let's say the object is moving at a velocity of maybe 8 meters per second. Do you understand? So for this, I'm going to have 8 minus 8 all over t. Do you understand? So acceleration is equals to 0 over t. So a is equals to what? 0. That is, acceleration is 0. You can see now. And that means that when an object is moving at a constant velocity, the force acting on that object is also what? 0. Do you understand? Please, it is very important that you note those 2 points. When an object is at rest, the net force of that object, the net force acting on that object is what? 0. So when an object is moving with a constant velocity, the net force at that the net force of that object is what? 0. Okay, as we progress to the second law of motion, we are going to delve more into this. Okay, just pay attention. Now let's proceed to the second law of motion. The Newton's second laws of motion state that the force acting on an object is the product of the mass and acceleration. Okay, this can be expressed mathematically as this: the net force is equals to the product of mass and acceleration. You can see that the net force is directly proportional to both mass and acceleration. Let's say the mass of an object is maybe 20 kilogram, and the acceleration is maybe 4 meter per second squared. Okay, now we are told to determine the net force. The net force is what? The mass, which is 20 kilogram, multiplied by acceleration, which is 4 meter per second squared. Okay, so the net force is what? 80 Newton. Is that not it? Because force is measured in Newton. Okay, now I want to pay attention. What if the acceleration is doubled and the mass is kept constant? If the acceleration is doubled, I mean the net force becomes 20 kilogram, which is for mass. If the acceleration is doubled and the mass is kept constant, so if you double the acceleration, we're going to have 8 meters per second squared. Do you understand? So I'm going to have multiplied by 8 meters per second squared. So the net force is equals to what? 20 multiplied by 8 meters per second squared. That means I'm going to have 160 Newton. So the net force is what? 160 Newton. You can see that the net force is directly proportional to the acceleration. As the acceleration increases, what happens to the net force? The net force also increases. Now let's say we tripled the mass of the object. So for this, the net force becomes 60. The net force becomes mass. The mass is tripled, so I'm going to have 60 kilogram. 60 kilogram multiplied by, and we keep the acceleration constant. So 60 kilogram multiplied by 4 meter per second squared. So the net force here will be what? 60 multiplied by 4. That is 240. So 240 Newton. Do you understand? You can see that means force, the net force, according to Newton's laws of motion, the net force acting on an object, the force acting on an object is directly proportional to the mass, the product of the mass, and acceleration of the object. Do you understand? So that's the summary of Newton's laws of motion. And also the Newton's second laws of motion, this can be used to express the relationship between the impulse and momentum of an object. Okay, don't forget that. Okay, let me just do it here. Force is equal to what? Mass is the product of mass times acceleration according to Newton's second laws of motion. Okay, and acceleration can be expressed as what? The change in velocity, that is v minus u all over t, change in t. Let me just put change. Okay, let me put change in velocity over change in time. Do you understand? Please, it is very, very important that you know this. Okay, so now let me call this equation 1, let's call this equation 2, okay? Let's call this equation 1, let's call this equation 2. Now, let me substitute the value of A as change in V over change in T as the value of acceleration in equation 1. So I'm going to have F, which is the force, is equals to mass multiplied by change in V all over change in T. Do you understand? Okay? Now, don't forget that momentum is the product of mass and velocity. Do you understand? Momentum is the product of mass and velocity. That means that, okay, let me just put it. The momentum, I just put capital letter M so that to differentiate it from this M. M, small letter m, in this case, is the mass of the object, and capital letter M is the momentum. Are you get what I'm saying? So momentum is mass multiplied by velocity. Velocity. So for this, momentum is equals to mass multiplied maybe change in velocity. So I can substitute the value of momentum into this equation. Okay, so I'm going to have, please, this is the equation that we are following. Okay, so force is equals to mass, which is small letter m, multiplied by big letter m. Big letter M, yeah, big letter M all over change in time. Okay, so the momentum can be expressed as change in momentum is equals to what? Mass multiplied by change in velocity. Do you understand? So the force now becomes mass multiplied by change in momentum, just like substituting change in momentum over change in time. Please, do you understand how I got here? You know, I have mass multiplied by change in velocity here, and change in velocity means that will also be change in momentum, because momentum is the product of mass and velocity. Do you understand? Okay, let's proceed. For this now, we have gotten here. If you multiply both sides by change in time, that will be force multiplied by change in time is equals to mass multiplied by change in momentum, and force multiplied by time is what? Impulse. Do you understand? Impulse is the product of force and time. Do you understand? So this will be impulse. Impulse is equals to mass multiplied by change in momentum. Mass multiplied by change in momentum. So you can see the relationship between impulse and momentum as described by the Newton's second laws of motion. Okay, so now let us proceed to the third laws of motion. Newton's third laws of motion state that for every action there is always equal but opposite reaction. This implies that if you apply a force, you are going to feel a force that is opposite to that force that you applied. Do you understand? Let's say we have a person jump on here. A person that is holding a ball jump on here and throw a basketball. You understand? Let me just put like this. I'm not really good at drawing. You understand? Just pay attention, okay? Now, let's say this person threw this basketball. He threw it. This person apply a force. You understand? According to the Newton laws of motion, this person is actually going to felt a force that pull his back. You understand? That is what Newton's laws of motion was talking about. That is, for every action, there is always equal but opposite reaction. That means for every force exerted on an object, there is always equal but opposite force. You understand what I'm saying? That is, Fa is equals to minus Fb, because that force is acting opposite to the direction of the force that is applied. In that case, the force is acting on this person itself. You understand? So now, let me ask you a question. Let's say the mass of this ball is 2 kilograms. Okay? And the mass of the boy, the mass of the person that throws the ball, is maybe 100 kilograms. Okay? 100 kilograms. You can see that this ball is going to move, is going to cover a long distance because there is a lower mass. It has a lower mass. You understand what I'm saying? Let's say the force that the person applies is 200 Newton, okay? Let's say the force that the person applies is 200 Newton. Therefore, that means that this force will also be what? 200 Newton. Now, let's calculate the acceleration of the board. The acceleration of the board can be calculated from the Newton's second laws of motion. According to Newton's second law of motion, the force is equal to what? The product of mass and acceleration. Okay? So make acceleration the subject of the relation. We're going to have force over mass. Okay? So acceleration of the ball will be what? Acceleration of the ball will be equals to force, which is 200 Newton, all over mass. What is the mass of the ball? The mass is 2. So the acceleration is 100 meter per second. Okay? Oh, 100 meter per second squared. You understand? Okay? Now let's find the acceleration of this person that threw the ball. You know, it's going to have a negative acceleration because he moved opposite to the direction which the ball is thrown. Okay, so for this I'm going to have A is equals to what is force? The force is also the same, that is 200 Newton. You understand? All over mass. The mass of the person is 100. That is what? 2 meter per second squared. That is negative 2 meter per second squared, because the force that the person experienced as a result of throwing the ball is opposite to the force applied towards the ball. That means this force will be what? Negative. Do you understand? That means that is how I got negative 2 meter per second squared. So when an object has an higher mass, you understand? When an object has an higher mass, and another object has maybe a smaller mass, we have another object just like this ball, have a smaller mass. If both objects travel at equal acceleration, the object that has a smaller mass will travel faster. It will cover a long distance compared to the object that has an higher mass. Do you understand? So let's say you are in a space, okay, and we have the sun, we have the earth here. This is the earth, and this is the moon. You are holding a ball, okay? Let's say you are in a space, and if you want to move towards the direction of the earth, which direction are you going to throw the ball? That's my question. Let's say you are in a space, you are holding a ball. This is the earth and this is the moon. Let me call this the moon. Okay, let's say you want to throw a ball. In which direction will you throw the ball? Of course, are you going to throw the ball upward? Are you going to throw it downward? Or in the direction of the moon? Or towards the earth? In order for you to move towards the earth, in which direction will you throw the ball? Yeah, you're going to throw the ball towards the direction of the moon. The reason is because as you throw that ball, the force that you exert on that ball, you are going to feel equal but opposite. In that case, you are going to move towards the earth. Do you understand? So if you throw this ball upward, you are going to experience equal but a downward force. You understand? And if you throw it towards the earth, you are going to experience equal, but you are going to move towards the moon. You understand what I'm saying? So if you want to move towards the earth, you throw the ball towards the moon. So Newton's third laws of motion tells us that for every action there is equal but opposite reaction. Do you understand? Okay, that's all about Newton's first, second, and third laws of motion. Okay, let's see how we can apply these laws to solve question.